Welcome back to Dapra's Milling Training video series, where we introduce important concepts for milling that will help you achieve the best performance from your cutting tools. Now, to be successful with your milling tool, the right grade of carbide, as well as the correct cutting edge type, must be selected from your cutting tool manufacturer's options. This video will introduce some of the terminology used to describe your cutting edge geometry and describe some of the most common edge preps in use today. As we've said before, one of the really good things about Indexable tooling is the vast array of various cutting geometries available for use, from shoulder milling to high feed to button tools, octagonal face mills, ball nose and backdraft finishing tools, and many more. Indexable cutting tools create opportunities to achieve high-performance material removal at low pricing, especially in comparison to solid carbide tools. With all this variety in cutting geometry, having to choose the correct cutting edge can be a confusing decision. Let's take a look at the most common options available and their characteristics. Recall from a previous video that there are 6 primary material groups for machining. There's standard non-heat treated steel, hardened steel, stainless steel, cast iron, exotics, and non-ferrous. Let's take a look at which cutting geometries or edge preps most often work well with each of these material types. There are 4 primary types of cutting edge geometries or edge preps that we'll cover for the purposes of this video. Now, before we talk about the characteristics of each edge prep, let's look briefly at the different components of the cutting edge so that the diagrams and our talking points make more sense. The first area is the primary cutting edge, the first point of contact between the cutting tool and the material being machined. This area may have a land added for strength, as shown here, or it may not. The second area shows the side of the insert, what is sometimes referred to as the flank. Now, this is where the normal flank wear that dictates the remaining tool life should generally be measured. The next area is the rake, where the chip created while machining will flow across the insert face. Now, this area may have a chip breaker or it may be flat. Finally is the hone, which is basically a rounding of the cutting edge to provide a bit more strength. Now that we know a little more about what we're looking at, let's discuss the cutting edge types. The first cutting edge type is the T-land, or K-land as it is sometimes referred to. This is the strongest edge prep and is characterized by its negative approach to the material at the primary cutting edge or land area. This pushes the cutting forces into the strongest part of the carbide, which is capable of absorbing incredible stress. The chip then flows across what is usually a positive rake face to roll up and away from the insert face. Now, this edge prep is usually reserved for tough steels, especially hardened steels, as well as most cast iron. The second edge prep is similar, except that the land is neutral rather than negative. So this strengthens the cutting edge, but to a somewhat lesser extent than the negative T-land. The neutral edge is usually a net positive edge, so while it has some good strength characteristics, it also can be suitable for a wider variety of materials. Now, the next edge shown is a honed edge and generally has little or even no land, which provides a more positive or high shear cutting action. This edge is the cleanest cutting of the 3, generating the least tool pressure, temperature, and burr, but is also the weakest in regards to shock and chipping resistance. This is generally the edge of choice for stainless steels, exotic materials, and high temperature alloys. Finally, we finish with an up-sharp cutting edge, which is suitable ideally for non-ferrous materials like plastics and aluminum, where the sharp edge is desirable and is not susceptible to chipping. Now that you have a better understanding of the makeup of a cutting edge and the various edge preps available, our next video will address choosing the right cutting edge for the material being machined. See you soon.